to solve this definite integral, we're using trigonometric substitution. The problem was kind enough to tell you what the substitution is, but if they didn't tell you, the fact that you've got the square root of x squared plus 4 is what leads you to think trigonometric substitution. And here's a little triangle that helps you with that substitution. The x squared plus 4 looks like the sum of the square root of the sum of the squares of the legs of a right triangle. And you want to use a trig function of either sine, tangent, or secant, where the square root is not part of the trig substitution and the x is in the numerator. So there we go. Tangent of theta equals x over 2, opposite over adjacent. So x equals 2 tangent theta, dx equals 2 secant squared theta d theta. And while we're at it, let's figure out what the square root of x squared plus 4 is in that denominator. X squared is 4 tangent squared theta plus 4. If we factor out the 4, tangent squared theta plus 1 is the same as the secant squared of theta. And now we can take the square root. That's the whole point of trig substitution, is to make that radical disappear. So let's see what happens if we substitute. We've got this 31. We've got dx is 2 secant squared theta d theta. In the denominator, x squared is 4 tangent squared theta. And we figured out that that radical is 2 secant theta right here. We cancel out, moving the 31 for us out front. We've got secant theta over tangent squared theta. We can use trigonometric identities to rewrite secant as 1 over cosine, and tangent squared is sine squared over cosine squared, which gives us this. So we've got 31/4 times the indefinite integral of cosine theta d theta over sine squared theta. Now we got to use u substitution. Let u equal the sine of theta, so du equals the cosine of theta d theta. And we still have the 31/4. This cosine theta d theta is du, and u over u squared, because u is the sine of theta. The antiderivative of 1 over u squared is minus u to the minus 1. So we've got, in effect, negative 31 over 4u. Now we got to get back to having x's. Negative 31 over 4u is the sine of theta from right here. Now we'll go back to our little right triangle. What is the sine of theta? Sine of theta is opposite over hypotenuse, x over the square root of x squared plus 4. That's what this is right here. And if I multiply the numerator by the reciprocal of the denominator, I get negative 31 times the square root of x squared plus 4 all over 4x. And then finally, don't forget the constant of integration. Now, if we took the derivative of this using the quotient rule, we would get this right here. So this is indeed an antiderivative of that original expression. There you go. Hope that helped. That's an example of trigonometric substitution to eliminate a radical as the sum of two terms. I hope that helped. If you need any, have any questions, post a comment.